Every time you do anything in this unit, you have the following tools available to you. Tools that you have, right? You can write this down because I'm going to actually make reference in your notes to this page, right? Tools, you can use the sum of all angles in a triangle. They always add up to 180, right? So that's one of them. The other one is the fact that a straight line, if it is cut in any way, right? If you know that this is 110, then you know that this must be 70, right? It adds up to 180 as well. So a triangle, all angles add up to 180. What do you call two angles that add up to 180? Supplementary. Right? Supplementary angles, we talked about that. You have Pythagorean theorem, and you have sine or cosine law. All of these are tools one can use to classify a triangle. So that's why I did trig before I did this unit, because you need it, right, to be able to do it quickly and accurately. Okay, these tools, like that is basically, sometimes you don't need much, right? But these are the ones that you can use. Sometimes it's as easy as this. Okay, so let me just have my key up here, and I will guide you through it. If you have a highlighter, grab it as well. What type of triangle has two equal sides and all angles less than 90? If all angles are less than 90, we know that that is an acute triangle. If you have two equal sides, that means it's isosceles. However, if there are two equal sides, can we also say that there will be two equal angles? Yes, yes, you can. So sometimes we use angles to figure out what the side lengths are. Okay? So there we go. So this would be an acute isosceles. I don't care the order you do them in. I usually do angle first and then the side. Okay, and you have three options for each. Next, this one is a bit controversial, and I should have done this before, but can we change the 2.2 to 1.2? There's a problem with it if it's 2.2. I won't talk about it right now, but so change the 2.2 to 1.2, then we're in business. So it says, is angle A congruent to B? Let's answer that first. And you look at this, triangle A has two sides that are 1.3 and one side that is 1.2. Triangle B has two sides that are 1.3, one side that is 1.2. You can therefore conclude that the angles in both of them are all going to be the same, and the side lengths, right? They share two side lengths that are the same. So yes, triangle A. This is the symbol for congruent, folks. Congruent means equals triangle B. And I add this to it. Both have common sides and angles. Right? So you can just conclude that they are you're actually talking about the exact same triangle, just flipped upside down. Okay. Next, what type of triangles are they? Triangle A, right? What will that be? You just look at the angles itself. Does this look like it's obtuse in any way? No, right? So then you can just go ahead and say that it's acute because of angles, and they have two sides that are the same, therefore it's an isosceles. Okay. And triangle B, it's the same one. So of course it's going to be acute isosceles as well. Okay. All less than 90, right? That's why we say acute, and two sides are congruent, right? That's why we call it isosceles. Explain your reasoning is basically doing something like this, or maybe sometimes having to find angles. That's what explain your reasoning is. It's showing your work. Okay. Next, this one pay close attention to because of the labeling. What type of triangle is X, Y, Z? So you go right X, Y, Z. We're talking triangle. So I'm going to use a highlighter. And I'm going to say that this triangle here is this one here. Okay, that's the triangle we're talking about. And explain using triangles X, Y, W. X, Y, W is right here. What's that A doing here? Something went wrong, guys. Just get rid of it. It wasn't supposed to be there. So this is triangle 1. Let's put a 1 under that one. And obviously, this is going to be that small one there. And why am I using both of these? Because I can figure out on this bigger triangle that 60 and 30 is 90 centimeters. Okay. In terms of its side length, what is it? What kind of triangle is it when you talk about side length? Scalene, right? Because they're all different sides. It's 90, 20, 40. So it's scalene. Why? All sides are different. All sides are different, or all sides measure something else. In terms of its angle, can I positively say what kind of it is? Is it acute, obtuse? It's definitely not a right triangle, is it? I would not think that this is a right triangle. Could it be an obtuse? It is? Lucas, you say it's obtuse? Why would you say that? It is actually. But why would you say that? Did you do any kind of math to figure it out for sure? You just guessed? Okay. Nothing wrong with that. Sometimes you need to guess and then figure out backwards. Yes? I use cosine law. But this is the beauty of this. You don't have to do a full-blown cosine law here. Watch carefully. Which one would be the largest angle if you had to pick? It would be this one here, this whole thing here, because this is the longest side. So this must be the largest angle if there is, right? So watch this. It's side, side, side. So I go cosine, if you, right? Cosine of that angle would be, no matter what you do, you start with the side that's across that angle first. The 90 comes here, subtracting, then you take the other two, square those. And we're going to stop there. Is this negative? If that is negative, we know it's what kind of angle? We know it's obtuse, right? We're not going to solve it. We're just going to stop right there. So 20 squared plus 40 squared minus 90 squared. That's negative. The top is negative 6100, which means it's obtuse. That sign tells me that whatever the angle is, I don't really care. I know it's going to be obtuse, so you can stop there. Okay? So therefore, this is an obtuse scalene triangle. So scalene, we just had to look at the numbers, right? 40, 20, 90. We knew was all sides were, but then we had to inquire a bit more about this angle right here to figure out whether or not it was obtuse. Does that make sense? What we did there, I just started the formula for cosine law. right? My formula sheet is gone right now, but I didn't do the bottom or anything like that. I didn't do any inverse because of that negative. Next, here, calculate all unknown interior and exterior angles using the given angles. So here I want you to focus on this part. At this corner right here, you have a straight line right there. So if this is 120 here, then this must be what? 60, right? Because this straight line here is what I focus on. Really accentuate that one there. That's what I focus on. So almost look at it this way, right? It's a straight line and they must add up to 180. So you just inserted an angle inside this triangle. This is 60 as well. Now you've got two angles. Every time that happens, you find the third one using the 180 minus 60 minus 60 right? Like you just use the sum of angles equaling 180. Take away the two you just found, you get 60 as well. What kind of triangle is this? All three angles are the same. All three sides will also be the same. So this is acute equilateral. We don't have to write the word acute, but I just say acute Y. All angles are less than 90. Equilateral Y. Watch this, all three angles are congruent. All three angles are the same. Therefore, all three sides are congruent as well. Therefore is just like three dots like that. Don't be scared of that wording. You can write it out if you want. But because all three angles are the same, I don't even need to know what the sides are. They're going to be the same. So I can conclude it's equilateral. Let me just, yeah, I think I just want you to make an arrow here and just say there's a straight line, right? It equals 180 degrees. Okay, next. This is, by the way, an exterior angle. This is an interior. So let's figure this out. What would that be right there? Well, it's again along the straight line here. Okay, so we're just going to go 180. Let's show our work. It doesn't take very long, right? So this is 42 degrees here. This is also 138, which means that that's 42 degrees right there. Okay, and so by definition, or we can find this one now. We found this one and this one. They happen to have the same angle on the outside, so 42, 42. This is 180 minus 42 minus 42. And that would be, if you do the math, this is 84, so that's 96 degrees. So what does this tell us? Bigger than 90. This right there will tell us that it's obtuse. This triangle is obtuse because of that. And what is it in terms of side length? Isosceles, right? Because this, if you go across the 42 and this 42, these two sides will be the same. So it's isosceles. And watch this, I'm going to highlight it with orange maybe. Right? Why is it isosceles? Because of these two sides or because of these two angles. Right? Two angles being the same tells you that two sides will be the same. Okay? Two angles that are congruent will tell you that there are two sides that are congruent as well. So that tells you, it actually goes both ways. Okay. Now we're going to go back to page 187. Write this down at the bottom of it. 187 of the notes. I just wanted a little bit of a review before I go back to our book. So there we go to 187. So get your notes. Go to 187. We're skipping a few things. And then we'll do the actual main lesson for today. So I'm getting you ready for that. $187. And I will at the top say see page 12 in workbook for examples, right? And I will highlight that so that when you flip through it, you can like, all right, I'm gonna go check that out. It just didn't make it into the book. Okay. The most common one will be the sum of triangles equal to 180 property. So let's put letters to this. A, B, and C. So this is triangle ABC, right? So if I ask you to classify this, you need that third angle because you have the second one. So angle B is just 180 minus 50 minus 47. Please do that even when you do trig, just do it, right? If you have two angles, find the third one. It's going to be helpful. So this is what, 97 and minus 180, so that's 83 degrees. So now you know this, right? This is 83. And you know two things now immediately, that all angles are less than 90, so therefore this would be acute, right? And scalene, right? Scalene, and so let's make the markings here for the text, right? All three angles are different. What happened here? Scalene. Okay. And I will make this note here. All angles less than 90. And here I will say all angles angels. All angles different. Write that down. That I made that observation that all angles were different, therefore all sides different. So I'm shortening it. Okay. So I know nothing about the sides. I don't know, there were no numbers, no markings. I just had to go by the angles to figure that out. Let's give this letters to the second one here, X, Y, Z. Okay. And I will kind of cut this here so that I don't mix things up. Look at this triangle. Please, this is a freebie, guys. This is a freebie. Here, look at this and that. The markings are your friend. So even if it said 10 inches, 10 inches, same thing. What do we know about the angle here? If this is 15 across that one, then this must be 15 across the other side as well. Which leaves us with angle Y. So angle Y is just 180 minus 15 minus 15. Angle Y is 150. Aha. What does that mean? The triangle is obtuse for sure, right? So this tells me it's obtuse. And what do I know about the side lengths? Well, it's fairly simple, right? It's isosceles. So obtuse, isosceles. I hope it's starting to make sense what we're doing here. I'm using whatever I can to be able to specifically say this is what it's called. Okay. Last one, and then we'll move on. Okay. And then you're gonna have to write down a bunch of stuff about properties. All right. So what do we know here? Oh, cosine law. Okay. If you use cosine law, there's nothing wrong. But I won't. This is why. This side is the same as that side, right? I look at it at the numbers. So watch this. Move across it, and you determine that this angle must be the same as the angle across the other side that is the same, which is this one here. Okay? Let's give this letters. A, B, C. If there are no letters, feel free to do that. So these are exactly the same. I don't know what they are though. But watch this. I will figure out angle B here because C is going to be the same. You take 180 degrees, you subtract the 60, it happens to be 60, right? And then that gives you 120, right? We split that in half to give you 60 degrees. Okay, so 180 minus that 60, I'm going to highlight that. Where did that 60 come from? It came from here. Why did I split that in half? Because these two angles are the same, so I can just split it in half, right? That's why I did that. So angle C is also 60 degrees. So I know that B is 60 and C is 60. What kind of triangle are we talking about? You should recognize 60, 60. It is definitely an equilateral. Acute equilateral. There's no such thing as obtuse equilateral. We can't have that. Okay. I will say this. Since all angles are congruent, all sides are congruent also. You're making that connection immediately. So somebody used cosine law? I think somebody did, yeah? Did you get 5.5 for this side here? So you could have used, right, this is a side angle side. You could have used cosine law, you get 5.5, you come to the exact same conclusion. So go for it. Like, you have my full blessing to do whatever you need to do to get there. Okay? But quite often it's not that much work. Okay, so I'm going to stop with triangles now. I need to start quadrilaterals to stay on track. Okay? So skip to page 190. There should be a blank page. I took out whatever the book had there because it was very, very bad. Students were always pulling their hair out. So this is my attempt to make it better. I hope it works. Okay, so at the top, I'm going to stop the recording and start a brand new one because